Monday. Happy Monday. We have finally gotten to the end of the new stuff, so to speak, after today. And so what we're going to do is take a look at section 7.5. And the reason why I'm just a minute late is because I was making an executive decision that I think would benefit you guys the most. So here's what I'm going to do. For section 7.5, I don't know if anybody even noticed, but I went back and I made the support assignment just a teensy tiny bit longer, and I took away the Hawks. Okay. One of the reasons why I did this is so that you can see exactly what I need you to know. And when I was working through the Hawks earlier, I didn't like some of those questions. And like I said to you guys before, I personally am unable to take away questions that I don't like. So I just took away the whole thing. So I went through and I put more questions of the type that you need into the support assignment. So I'm going to update the calendar. There is going to be no Hawks for 7.5. However, the support assignment is still going to be due, and it'll be questions that you need to be able to do. So I think that will help out a little bit. Okay, make you guys a little bit more happy. So before we get started with the last section, are there any questions, any concerns, anything that we need to talk about before we go ahead and get to work? While everyone's here, while I'm right here too. Okay, so then let me go ahead and get my whiteboard up here, and then we will see, maybe, there we are. We'll see what you guys think. Okay, so get a little chat over here. All right, so like I've said, we've reached the last section finally, right? This has been the semester that just won't end. So we've reached the last section, and it is going to be 7.5. And in this section, we are going to talk about exponential, so just expo, and log equations. Whoa, okay, expo and log equations. And so what we're going to do is we have several different types of problems in this section that we are going to solve. And we're going to use the properties that we've already learned about in the previous section in order to do that. And so there's a few things that I want to write down as far as sentences go. And then basically it's just a matter of, hey, look, here are the different types of problems. Let's do them. Okay, so let me get, hold on, I heard my phone make a sound and it sounded like a remind sound. Yeah. Okay, so a couple sentences that I need to write down first that I need you to make sure that you understand and that you have. So the first one is this. Logarithms. I'm trying to write much neater because I have been out of control. Of negative numbers are by definition undefined. Okay, so what's going to happen is while we're solving these equations, some of the answers that we might get, just like we have in the past when we solved equations, could be a negative number. And if that's the case, we have to make sure that it's not going to make our whole problem negative, because we can't actually take the log of a negative number. That's what that sentence means. And so there will be some examples where we see this, and instead of us saying, oh, the answer is -10 or whatever, we have to say, oh, hey, you know what? Since this is negative, it's actually undefined. So that's the first thing. And the second thing that I want to write out, and I might have to do a little word explaining once I get this written, is when we are going to solve, okay? If we have, let's see, how do I want to put this? If we have one log on each side of the equal sign, then we set the stuff, and I'm going to put stuff in quotes until we have a chance to look at it. Hold on a second. I can't talk and write. You guys should know that by now. Then we set the stuff equal. And once we see problems, this will make much more sense to each other. Okay, so take a sec, just jot that down. Once we see this, if we have logs on both sides, then we just go ahead and set the stuff equal to each other and we're ready to go. The important part is if we have one log on each side. Okay, that's going to become very important when we progress and we see our examples. All right, so far, just all I have room for are these two sentences, but before I scooch over to the next screen and write a few more, are there any questions just on what these say versus what they mean? Okay, so then the next page, okay, the next sentence that we're going to write is if we have two logs on one side of the equals, we must condense first. And we talked about condensing last time. Condense first, then solve. Okay. If we have two logs on one side of the equal sign, we must condense first, then solve. Now, the last thing that I'm going to write down here is going to make absolutely no sense for about 10 minutes. Okay, but I got to write it now just so I can say refer back to your notes. This sentence is going to be silly, okay, but you got to bear with me because I know what's coming. And the last sentence that I want to write before we dive into these problems is this. If you need to find the time, and I'm going to put time in quotes because it's going to be the variable t in some of our problems that we're going to see down the road. If you need to find the time, divide ln divide. And I know that sounds silly, but it's one of my little tricks that'll stick in your brain. If you need to find the time, divide ln divide. But you got to give me a few minutes to get to that problem. Okay, so those are the four little things that we need to remember for now. The logs of a negative number are undefined. We need to make sure that we only have one log on each side of the equal sign. If we start out with two logs on one side of the equal sign, we have to condense that first, then we'll solve. And in the problems where we need to find the time, t, our problem setup is going to be we're going to divide, then we're going to take the ln, and then we're going to divide again. That's what these four sentences mean. Okay, so again, I know this is weird and silly and you know what, but are there any questions just on what these three things, or these four things say rather, not what they mean, but before we get to the part where I show you what they mean? Anything? Can we still hear me?
Yeah.
Okay, just making sure because I'm getting nothing. Okay, all right, so then here's what we're going to do. We are going to dive right in and we are going to start doing some of these problems, and then these sentences will start making more sense, okay? And as we progress through these problems, please let me know how it's going. So here we are with example number 1, okay? And the problem is 3 to the 2 minus 5x equals 11. Now, the other day, we had a problem similar to this, and our goal was to get this number 3 and this number 11 to have the same base. And we did that by asking ourselves, can the number 3 be raised to a power and give us 11? Well, the other day, most of those questions we answered with the word yes, and then we went about our business. But now, today, can we take the number 3, raise it to some nice, neat little power that I can quickly find, and give me 11? Is that possible?
No.
No. Okay, so when the answer to that is actually no, well, we still have to solve for x, but x is still way up here in the variable spot. Okay, and we don't, or not in the variable spot, and the exponent spot. Okay, it's right there. Now think back to, I guess it would have been Thursday. We did we had some rules. What rule or how were we able to bring this variable down? Remember how we did that? When we were doing
the square root.
Not the square root. Remember when we were condensing and expanding? And one of the rules was like if we had, log base b of x and it was raised to the r power, we were allowed to bring this down and pull it out front because that was the rules of logs. Remember how we did that? Well, if we want this exponent to somehow get out of the exponent area because I can't solve for x if it's way up there, then what I'm going to have to do is I'm going to have to take the log of both sides because the log properties are what allow us to do that. Okay, so here's what we're going to do. Okay, so we have to kind of remember back to some of the stuff that we have done. So watch what we're going to do. remember, I think I told you guys this the other day that I really enjoyed using the ln because it was going to come in handy later. Well, it's later now, okay? And so here's what I'm going to do. I'm going to take the ln of both sides. Because remember, what I do to one side, I have to do to both. All right? Now, since I'm dealing with a log function and having the ln out there, then guess what I'm allowed to do? I'm allowed to take this exponent and bring it out front. That was a rule from last time. And so because I've taken a log, even though it's in the form of ln, it's still a log, what I'm going to do is I'm going to bring out this exponent and I'm going to have 2 minus 5x. The ln of 3 is still there. That is still equal to the ln, of 11. Okay, so take a sec. Think about what we did. We said, hey, we need some logs. So we brought in the ln. We said, hey, look, this is an exponent. We brought the exponent out front. And here I am now. Any issues so far? Okay, and so now x is at least in the normal equation, so to speak. It's no longer up in an exponent. At least it's right there. Okay, so here's what's going to happen. X is stuck inside these parentheses, and we learned a long time ago, if we have a plus or minus sign with some parentheses, that's called a quantity, and we can't just pull it apart until the parentheses are gone. And so what's happening right here is multiplication. And so if I have multiply by the ln of 3, guess what? I can divide by the ln of 3, and that will get rid of this. Now notice, you might have your calculator out or you might not, but notice I haven't even mentioned the word calculator yet. So what's happening is you're going to leave it like it is. We're not going to type it into the very end. So we're going to have 2 minus 5x equals the ln of 11 divided by the ln of 3. Just like that. Okay, what do you think about that? So far, so good?
Wouldn't the ln's cancel for that one?
No. All right, because if this were, so let me back up for one side note. If this said 11x over 3x, then sure, the x's would cancel. Okay, but since this is an actual function, the log is an actual function, the function itself is not going to cancel. Okay, so we have to have the ln up there. Eventually, we're going to do some dividing, and the ln's are going to, I don't like the word cancel, but they're going to go away, as in I'm going to type them into my calculator, but not yet. Okay. All right, so now we still have this little x right here, but at least he's in much better shape for me to get by itself. Well, I got to get rid of this 2. Well, that's just a nice, neat positive 2. What's the opposite of adding 2? Well, subtracting 2. And what I do to one side, I'm going to have to do to both sides. Okay, so the 2 is going to go away. And so now I'm left with negative 5x equals, notice again, I still haven't typed anything in yet. So I have the ln of 11 divided by the ln of 3. Now this minus 2 is a big minus 2. It's on the outside. And then I look back at x and I say, okay, well, what's happening to x? It's being multiplied by negative 5. What's the opposite of multiplying by a negative 5? How about dividing by a negative 5? And so what I do to one side, I have to do to both. And so remember the other day, we had exact answers and then we had decimal approximations. We're going to have that again today. And so what's going to happen is, let me get some over here on the left-hand side. Let me make a little bit more space. What's going to happen is we're going to write it out exactly, and then I'll show you how to type it into your calculator so that you can get your decimal approximation, and then we're done. And so as far as my exact answer goes, I'm going to have x equals the ln of 11 divided by the ln of 3 with a big minus 2, and then that whole thing is being divided by negative 5. That's big and bad and ugly, but guess what? This is my exact answer. Now, pause for a moment, reflect on what we did. Let me know your questions because we're almost done. The last thing I need to do is type this into a calculator and get x is approximately something. Okay, so what are your thoughts so far? So this means, your silence means everything's peachy? Okay. All right, so again, I can't see your calculator, you can't see my calculator. But here's what I'm gonna verbally and write it down. Here's how I want you to type it in. Okay? So in your calculator, are we ready for this first of all?
Yeah. Ready.
All right, so here we're gonna go. Okay, you're gonna type the ln button. When you do that, a parenthesis pops up. You're gonna type in the number 11, close parenthesis. Then you're gonna hit the division button. Then you're gonna hit the ln button again, a parenthesis pops up. You're gonna type 3, close parenthesis. Do me a favor, hit enter right then, right there. Okay, so let me do that too and see what you should get. So the ln of 11 divided by the ln of 3. It's going to give you like 2.18 something. Okay, make sure you got that. Now, the next thing you're going to hit, excuse me, is a subtract 2 button, or not button, but just subtract 2 from that answer. Then hit enter again. When you do that, you're going to get like 0.18 something, okay? Last thing you're going to do is hit the divide by 5 button, and then you're going to hit enter again. And when you do that, the final answer that you should get is the total answer for this guy. X is approximately negative 0.037. This is my final decimal approximation. So with your calculator, whatever steps you have to take to get that answer, take a minute here and, excuse me, and prove to me that you can.
I got it.
Okay, so just sit tight for a minute and let me hear some other responses.
I got it.
Okay. So, okay. Ooh, okay, good. So guess what? We're done. Okay, so the new part here for this particular problem was the fact that when our x value was given to us, it was in the exponent area. And in order for us to get the exponent out of there, we had to introduce the ln. And what I did to one side, I had to do to both. And again, you're noticing we didn't touch that calculator until the very end. That's the first type of problem that we're going to solve. That's an exponential problem. We turn it into a log problem, essentially. Questions, problems, comments, concerns on number 1? Okay. So let's see. Okay, no, that was number 1 then. All right, so then let's take a look at another type of problem that looks similar-ish, but is done just a wee bit differently. Okay, so here's number 2. We're starting out with 5 to the 3x minus 1, and that is going to equal 2 to the x plus 3. Now, this looks very similar to the problem that we just did. Okay, however, in the problem that we just did, that exponent didn't exist. Okay, but now it does. And so what has to happen is we cannot just worry about one base. We have to worry about both bases, so to speak. So our question is there any possible way that we can take the base 5 and the base 2 and somehow make them the same? Is there any way that 5 to something equals 2 and 2 to something equals 5? No.
No.
Okay, and so again, we got a big fat no. And so here's what's going to have to happen. We're going to have to somehow get the x values that we need, which are right here, out front. And what's the rule that allows us to bring exponents out front? What did we do in the last problem, step 1?
ln.
Yeah, and so this time we're going to do the same exact thing. The only thing that's different is now we're going to have this little guy to worry about, but we're going to start out the same way. So we're going to say, all right, well, let's take the ln of both sides. Okay, and that is just me bringing in the log function, which allows me to pool my exponents out front. Sorry, my throat's really dry this morning. I ate like so many sunflower seeds last night while I was binge watching The Walking Dead that I about can't feel my lips. So just be careful if you're eating sunflower seeds because you can get out of control pretty easily. Okay. Once we've written the ln on both sides, again, the rule is that we are allowed to bring these guys out front. Okay, and so that's what's going to have to happen. And so then we're going to have 3x minus 1 times the ln of 5 equals x plus 3 times the ln of 2, like that. Okay, now, generally speaking, on the last problem, this little x plus 3 wouldn't have been a problem, and we would just divide by the ln of 5 and we are about our way. But we can't do that. And so, generally speaking, in the past, how have we gotten rid of parentheses?
FOIL?
Yeah, FOIL, but just
distribution.
Yeah. And so here we're going to have to do that. So we're going to say, okay, well, what is 3x times the ln of 5? Don't overthink it. It's just 3x ln of 5. And then I say, okay, well, what's negative 1 times the ln of 5? Well, it's the negative ln of 5. Okay, we know all these processes. We cannot overthink this stuff. Okay, because otherwise it's going to be bad news if we're putting too much thought into this. So let's do it on the other side. So equals x times the ln of 2. Well, that's just x ln of 2. And 3 times the ln of 2. Well, that's just 3 times the ln of 2. Right? No big deal. I need to hear someone say it because I don't know.
Yeah, you're good.
Okay. All right. So then what's going to happen is we're going to say, all right, well, just like last time, okay, just like when we've solved equations in the past, we want all of our x values to be on one side. Well, look, here's an x value and here's an x value. And we want all of our non-x values to be on the other side. Well, this is a non-x value and this is a non-x value. And so what that means is we have to move this guy over here somewhere, and we have to move this guy over here somewhere. Does that seem pretty straightforward? I mean, that's what we've done in the past, right?
Yeah.
Let me just start fresh because I'm running out of space. Eraser. Okay, so let's do that. All right, so on the left-hand side, we are going to, hold on, let me get some space here. We are going to subtract the x ln of 2 from both sides, and we are going to add the ln of 5 to both sides. Okay, and then I'm going to come up top because I'm running out of space here. So what that's going to give me on the left-hand side is 3x ln of 5 minus x ln of 2. And then, of course, this is going to be gone, equals 3 ln of 2 plus ln of 5. So basically what we've done is we've picked two terms up and we've swapped their locations. Okay. And so now we're going to say, all right, well, we've got all of our x values, which in this case happens to be 2, on the left-hand side, and all of our non-x values on the right-hand side. So in order for us to just get one x on the left-hand side, here comes our favorite F word back to us. We're going to have to factor this out. We're going to have to say, okay, well, if I took the x out of these first two terms, what's that leave me with? Well, if I pull the x out of this, what's it leave me with?
3 ln of 5.
ln of 5. Perfect. Subtraction sign. If I pull the x out of this, what's it leave me with?
ln of 2.
Absolutely. Over here on the right-hand side, I've done nothing so far, so it stays exactly the same. All right, so think about now, well, is x kind of isolated? Almost, right? It's on the outside by itself. What's happening between this x and these sets of parentheses?
Multiplication.
Yeah, and what's the opposite of multiplying by all this stuff?
Divide it.
Yeah, so we're going to divide both sides by 3 ln of 5 minus ln of 2. So, whoops, oh my gosh. 3 ln of 5 minus the ln of 2. Now over here, all of this messy, nasty stuff is going away. And we're just going to be left with our x value. And so theoretically, or technically, I suppose, we've solved for x. And just like last time, we are going to have an exact value, and then we're going to type it into our calculator, and we're going to have a decimal approximation. So our exact answer is x equals, and this is a big one, but that's okay, 3 ln of 2 plus the ln of 5 all over 3 ln of 5 minus the ln of 2. This is my exact answer, 100% exact with no decimal approximations whatsoever. So let me pause there for just a moment. So we took the ln of both sides. We pulled our variables out front. We got the x, or we distributed to get rid of our parentheses. We got all the x terms on one side, all the non-x terms on the other side. We factored out the x, which was this step. We got x completely by itself right here, and that's our exact answer. What are your thoughts to that point? It's a lot of writing, but the cool part about it is you already know how to do all these processes, okay? So any questions, any issues with this part? Because now we have to type this into the calculator, and we have to make sure that we're typing it in perfectly. All right, so I'm going to take the silence as a, yeah, you're good. So before I do this, in case you want to jump ahead of me, the decimal approximation you should get is 8.892. Okay, so if you're following along, here's what you're going to type in. You're going to hit the number 3, okay? Then you're going to hit your ln button, and of course a parenthesis is going to pop up. In there, you're going to type 2. You're going to close that parenthesis. Then you're going to put the plus sign, then the ln button sign again, and then, of course, the parenthesis will come up, and then you're going to hit 5. Then you're going to hit enter. So 3 ln of 2 parenthesis plus the ln of 5 parenthesis enter. That step is going to give you 3.68 blah, blah, blah. Now, again, I don't care about that 3.68. I'm just letting you check yourself along the way. Next, you're going to hit the division sign. Then you're going to put a parenthesis, okay, because now we're down here in the bottom. So you're going to hit the 3 button, the ln button, the parenthesis pops up, you put a 5, you close that parenthesis, then you put your minus sign, then you hit the ln button again, the parenthesis will pop up, you hit 2, you close your parenthesis, and remember we had said, since we have to make sure that we have as many parentheses opening and closing the same manner, the same direction, so you're going to an additional close parenthesis. Then you're going to hit enter again. And when you do that, this is what you should get. Okay, so take a sec, practice this in whatever way your calculator needs it to be done. Okay, maybe you could do it all in one swoop, whatever. And then that's it. So take a second, make sure you get it, let me know. Anybody? Okay, Lakin got it, okay.
I got it.
Okay, good, good.
I got it.
All right, cool, cool, cool. See, guys, this isn't so bad. It just takes a little bit of practice, okay? Okay, page, okay, good. All right. So those are the types of exponential functions that we're going to see, okay? And basically what we're doing is just like the other day when we saw exponential functions, we turn them into log functions essentially. So what are your thoughts on 1 and 2? Basically, and I think that I mentioned to you the other day that I kind of have a love affair with the ln and I use it all the daggone time. This is why, because we use the ln so much. Okay, so let's slowly transition ourselves towards the functions or towards the equations that already have logs from the get-go. Okay, so 1 and 2, we good for now? We can always come back, but are we good for now?
Yep.
All right, so then let's take a look at example number 3. And this is going to look super familiar as we've done these problems already, just kind of a reminder. So we've already done a problem that looked like this. So in this one, we're going to have log base 7 of 3x minus 2 equals 2. Now, somewhere in our notes, it had said, I don't think, it wasn't from today, but when we have a log function, typically we need to turn it into an exponential function to solve it. And in this case, since I only have one log, I'm able to do that. And so this is where I have to draw my arrows. And so from the other day, where's my pen have to start? For me to
7 to the 2.
To the 2, and then from the 2
and
to the
2 to the
becomes 7 squared equals 3x minus 2. Perfect. Well, now all I got to do is solve for x. And since x is, right here, he's manageable. He's not in the exponent. He's good to go. So 7 squared is just 49. That equals 3x minus 2. Well, I need to add 2 to both sides. So I'm going to get 51 equals 3x. I divide both sides by 3. I get x is 17. Bam. Done. We've done these problems. You got this in the bag. That was a piece of cake, right?
Yeah.
Okay. Now, don't write this. Just watch with your eyeballs, okay? Because we talked about this, but we haven't done it yet. What if, in all of my solving, I were to get x equals negative 17? Okay, let's just say for just a second that I got that.
You can't have a negative
You
17.
can't have it. Exactly. So if it were the case that I got 17, I would have to scratch it out, and then I have to put undefined. So we're going to see that in a minute, okay? But in this particular problem, the true answer actually is 17, and I'm done. So what are your thoughts on 3? Piece of cake when I just have one log. All right, so then let's take a look and see what happens when I have 2 logs, okay? Because maybe that happens. So let's take a look at 4 and see what kind of, what we have to do here. So what if we have, let's say, log base 2 of x minus 1 plus log base 2 of x minus 1 equals the number 2. And so according to our notes, it says from today, if we have, 2 logs on one side of the equal, we have to condense it first. And so we say, well, we definitely do. We have 2 logs on one side of the equal sign. I can't draw any arrows yet, so I have to condense this first. And so we think back to Thursday, and we think back to this MADS business, okay? And we say, all right, well, if I'm condensing, look what's happening, addition. And so in order for me to work backwards and condense this, if I started addition, what am I going to turn it into?
Multiplication.
Exactly. So here's what will happen. I will have log base 2, and then this is the stuff that's being multiplied. So I'll have x plus 1 times, no, I will not have x plus 1. I will have x minus 1 times x minus 1, and that will equal the number 2. Okay, and so now my question is, do I just have one log?
Yeah.
And so now that I just have one log, I can draw my arrows. And so I'm going to get 2 squared equals x minus 1 times x minus 1. Okay, well, what is 2 squared?
4.
And how do I get rid of all these parentheses?
FOIL.
Uh-huh. And so I'm going to have x squared minus x plus 1. And so now, based on the fact that this is raised to the second power, that tells me lots of things. What are some of the things that tells me? How many answers am I looking for here?
2.
2. And how do I get those 2 answers?
You need to break up that into like 2 separate cases.
That's right. And what's the process of me doing that? Anybody remember what that's called? Starts with an F. Factoring.
Factor.
So I got to get this thing right here so that I can factor. And if I have to factor it, I know that it has to be set equal to
0.
Okay, so that means I need to take this 4 and scooch it over. And so I'm going to have x squared. These x values will combine and give me negative 2x. And then 1 minus 4 is negative 3. And that's going to be set equal to 0. So let me pause for just a second. So I condensed first. I drew my arrows and now I have to FOIL, which I did. And then I say, oh, because it's x squared, that means 2 answers, which means I have to factor. And so in order for me to factor, it has to be set equal to 0. Okay. And so then I'm going to open my parentheses over here, my 0 in, and say, okay, I need 2 numbers that are going to multiply together to give me a negative 3 while adding up to give me a negative 2.
Minus 1 and negative 3.
Okay, minus
Or
1.
positive 3. Or
Yeah.
positive 1 minus 3.
I got you. Okay, so how about when we factor this, we'll have x plus 1 times x minus 3. Okay, if we're doing it the long way, we know that then x plus 1 must be 0 or x minus 3 must be 0. And then, of course, if we solve, we're going to get x equals negative 1 or x equals 3. Now, the very first note that I wrote for you was that you can't take the log of a negative number, right?
Oh, so you can't have the negative 1. It's not an answer.
Exactly. So we're going to go bam, bam, and we're going to say, you know what? This is my solution. Now, here's the thing. If we were to take these numbers and plug them back into our original problem, that's how you can check yourself if you're unsure. Let's say for just a second that we take x is negative 1 and we put it right here. Negative 1 minus 1 is negative 2. You're trying to take the log of negative 2. You can't. So what if we put the 3 right here? 3 minus 1 is just positive. Oh, yeah, okay. And so this is, we're just kind of, you know, I'm kind of unofficially telling you, you don't have to check it every time. If it's negative, you can't do it. If it's positive, there's your answer. And so if this were Hawks, let's say, but of course you're not doing Hawks, I suppose, but let's say this is your worksheet. You're going to say, bam, this is my answer. And you got to make that clear to me. And now we're totally done. So take a second. I need a drink. You look at this problem. Tell me what you think. All right, so what are our thoughts? Questions, issues, problems, what?
If they both come out negative, then the whole answer is undefined.
That is correct, yes. And there will be a problem on your worksheet where you get a negative answer and your answer is undefined. Yep, that would happen. So Sebastian, the answer to your question that she just read out loud, the answer is yes. They would totally be undefined. Okay, let's take a look at another one like this, okay? Except we're gonna have logs on both sides, okay? And we're gonna see what happens when we do have that. So if you look through the notes that we just wrote at the beginning, I can't even remember what number this is. Is this
5?
5? Thank you. Okay, I went a little out of order in my notes, so I'm skipping around a little bit. So let's have log base 5 of x equals log base 5 of 2x plus 3 minus log base 5 of 2x minus 3. Okay, so in the notes today, again, we can only have one log on each side. Well, I'm good over here because I have only one log, but darn, I got 2. So I got to take care of that. All right, now let's pretend for just a second that we did. The notes go on to say that if I have a log on one side and a log on the other, and there's just one, then I take its stuff and I set it equal to each other. Remember that? And I said this will make more sense later. Well, now it's later. Okay, so let's go back to the problem and let's make on the right-hand side, let's just make us only have one log. And so according to the notes, when we have 2 logs, we have to condense first. And so if I look at this, I see a subtraction sign. And because I see a subtraction sign, how am I going to condense this side of the problem?
Divide.
Yeah, so log base 5 of x stays the same. This turns into log base 5, and then 2x plus 3 is on top, and 2x minus 3 is on the bottom, just like that. And now I've condensed it. And so this part, gone. Don't need it anymore. What are your thoughts so far? Okay, so we condensed it. Now, again, in the notes, it says when we just have like, one log on each side, which in this case we do, we just remember how I wrote the word stuff. I put it in quotes like this, and I said we take the stuff. Well, guess what? Here's this stuff, and here's this stuff. And so we're literally going to say x equals 2x plus 3 over 2x minus 3. And the whole idea that we're dealing with a log for the time being is gone. We're just solving for x. Now we know that we can't totally forget about logs because it's going to take effect, or it's going to affect our answer. But for the time being, we're just trying to get x by itself. And so we look at this and we say, okay, well, here's a denominator that I don't want. Generally speaking, how do I get rid of a denominator that I don't want?
You can multiply it on the top.
Yeah, so I'm going to multiply both sides by 2x minus 3. So times 2x minus 3. Okay, so on the right-hand side, that's gone, which is great. Now on the left-hand side, I have parentheses, which means I'm going to have to distribute. So when I do this, I'm going to get 2x squared minus 3x. This 2x plus 3 is still the same. Okay, so now, since I see this x squared, that tells me lots of things. What are those things it tells me?
2 answers.
2 answers. And how do I get those 2 answers? Our favorite F word. Factor. Okay, and so in order for me to factor, I know that all this stuff has to equal 0. So let me minus 2x and let me minus 3. Minus 2x and minus 3. Okay, and so what's going to happen is over here, I'm going to be left with 2x squared. If I have negative 3x and I minus 2x, that's a negative 5x. And I didn't have any whole numbers, but I'm minusing 3, so I'm going to have a minus 3, which is equal to 0. Now, we got to dig way back, way deep. And hey, look, this isn't just a 1, so I can't just factor it super easily. I got to use... yeah. See how all this stuff is intertwined? You never would have guessed all this, would you?
Oh my God.
Oh my gosh. Okay. All right. So let's do that. Okay. And so we look at this and we say, all right, well, AC 2 times 3 in this case is 6. And we know it needs to be negative. So we list out the factors 1 and 6 and 2 and 3, and that's it. And we say, okay, well, we need 2 numbers that are going to multiply together to give me a negative 6 while adding up to give me a negative 5.
2 and 3.
Are you sure about that?
Negative 6 and positive 1.
Yeah. Negative 6 and positive 1. So I turn this into 2x squared plus 1x minus 6x minus 3 equals 0. And then I group the first 2, I group the second 2, and I say, okay, what do the first 2 terms have in common? Just an x. When I divide the x out, that leaves me with 2x plus 1, parenthesis. Remember, we said no matter what the sign is, it comes straight down. And I say, okay, 6 and 3, they share the number 3. Well, this is negative 6x divided by negative 3, positive 2x. This is negative 3 divided by negative 3 plus 1. And so then I say, okay, well, what this gives me next, I'm going to come back over here to the left because I'm running out of space. Oh. Sorry, this dog is scratching at the door. I don't know what he wants. Okay, so what this gives me then is going to be, I'm going to be left with 2x minus 1 times x minus 3 equals 0. And then I know that since I'm trying to actually solve for x, I will have to take each of these teeny tiny pieces and set them equal to 0. So that means 2x minus 1.
Isn't it 2x plus 1?
Yes, thank you. Don't know what happened there. Whoa. I'm glad someone's on the ball because it's been like a true blue Monday over here for me. Plus 1, okay, equals 0. I don't know why I put those in parentheses either. They're not needed. And then I'm going to solve each one of these little guys. And so quickly, I'm going to get x is equal to a positive 3. Or I'm going to see 2x is equal to negative 1. X is equal to... Whew, okay, after all that work, I finally have 2 answers. Now, I have to keep my head straight, and I have to say, oh, I actually am solving a log problem, so to speak. And remember, I can't take the log of a negative number. And so what's my answer
Right.
going?
3.
Yeah, just 3. And over here at the -1/2, I'm gonna scratch it out. Maybe I put undefined, whatever. But however it is that you're doing it, I need to know, hey, Amanda, this is my answer, and this is not. And so now I'm done. Now, was that a lot of work? Yes. Have I done every single one of those processes before? Also, yes. Okay, so I got to open the door and let the dog out. Take a sec. Let me know what kind of questions you have. All right, so what do you think?
It's not that bad.
It's really not. It just takes time. Okay, it just takes time, and I know that with us being so close to the end of the semester, time is not something that we're that we're really wanting to give. Okay, believe me, I know.
After doing these examples too, I'm glad there's no Hawks on it.
I know. That's why I made that decision. Okay, because listen to what Hawks was going to make you do. Hawks was going to make you do a problem like this, but use the quadratic formula. It was a disaster. So
That would be lengthy.
yeah. Molly, the base of the natural log is log base e. And it's written as this, the ln or log base e, like that. All right, any other questions or problems before we move on? Okay, so now remember that last sentence I wrote you in the notes? It says, if you need to find the time, divide ln divide. Now we're going to do that so that that makes sense, because right now it's just a weird little poem, okay? But it actually is it actually has meaning. So we're going to do a problem that deals with compound interest. And the formula that we had for that was A equals P, parenthesis, 1 plus R over N to the NT, okay? Now, what we are going to do in this particular section is solve for T. Now, if you think back to the last time that we saw this problem, we have already learned how to solve for A. Maybe we solved for P, and we've also solved for R, but now we have to solve for T. And if you look at T, T's stuck up there in the exponent. And how do you think we're going to get that T out of the exponent? What did we just do in the previous problems to get the X values out of the exponent?
Make it
Take
allow.
the ln and then bring that to the front.
Exactly. So that's what we're going to have to do here, okay? And you're like, oh gosh, but we just did that like 4 or 5 minutes ago? I don't know. So here's the problem, okay? That's just the setup. Here's the actual problem. You have $5,500, okay? But you need $6,000, okay? You're going to invest this. The interest rate is 4.8%. It's compounded monthly. Okay. The question, how long till you accumulate your $6,000? Okay, so I'll give you a second to write it all out. So you have $5,500 right now. Let's just put a $sign right there. But for some reason, you need a little more money, okay? And so what you're going to do is you're going to take your money to the bank and you're going to put it in an account. The interest rate is 4.8. It's compounded monthly. My question to you, how long is this going to take for you to come up or to get that $6,000? So before we do anything, what we need is to list out everything that we know from our problem so that we know exactly what it is that we're trying to find. Whoops. Oh, I've hit a wrong button. Okay, so here we go. So we're going to read through the problem and then we'll list everything we know. So the first question is, or the first sentence says, you have $5,500. Well, which variable is represented by 5,500? That's your principal. So P is 5,500. Okay. So we got this little guy. Okay, but you need 6,000. So 6,000 is going to represent which variable?
The A, what you want to have at the end.
Exactly, because that's your future value, how much you want or how much you need to have then. Okay, keep going. The interest rate is 4.8%. Which variable is that?
Your rate.
Okay, and this is some of you guys had problems with this on the homework that I commented back to you. You have to pick this decimal point up and scooch it over 2 places to the left. So it's going to be 0.048, like that.
You can also put it in your calculator as 4.8% and hit enter, and it'll give you 0.048.
Okay, not everyone's calculate. Like, for example, I have my TI-84 graphing. I personally cannot do that. Okay, so if you're unsure, what you could do, anyone could do this. You could type 4.8 into your calculator, and you could hit divide by 100, and it'll scoot that over for you. Okay, I hesitate to tell people with that percent sign because not everyone has one of those. Okay, but if it works for you, then do it by all means. Okay, so we got this taken care of. The next thing that we see is compounded monthly. What's monthly going to represent?
N,
N. And if something happens monthly, how many times a year does it happen?
12 times a year.
Perfect. Okay. And then of course, how long? Well, that's T. That's what I'm trying to figure out. I don't know how long. Okay. That's what we're trying to solve. All right. So everyone on the same page here? We have our variables, all the variables that we know. All right. So what I'm going to do is erase some of this just so I have more space. Okay. So I'm going to erase the problem written words, and we're going to do it, using just the numbers and the formula. And so what we're going to do is take all the letters that we just wrote down, and we are going to pop them into their respective locations, and then we're going to solve for T. And the sentence that I wrote, if you need to find the time, which is exactly what we're trying to do, we're going to have to divide, then take the ln, then divide again. Okay, so here we go. So our formula is going to be 6,000 for my A value, equal sign, the P value, which is 5,500, parenthesis 1 plus my rate, which is 0.048, divided by my N, which is 12. Now remember, in the past, we went ahead and said, oh, let's find my NT real quick, because I don't want to have to do that in my calculator. Well, if my N is 12 and my T is T, that's just 12T. Exactly. So this is going to be raised to the 12T. And so again, our goal is to solve for T, which obviously we see right here up in that area. And so remember the notes, it said to divide, ln, divide. So the first thing we have to do is divide. Well, here's what we're going to divide. It'd be super great if this guy wasn't here because he's just in the way. So
yeah.
yeah.
So we're gonna,
So we're going to divide both sides by 5,500. And so now 5,500 is gone. Perfect. So we divided. Check. The next step says we're supposed to take the ln. Well, what I do to one side, what's the rule? What I do to one side, I absolutely must
do to the other.
Okay, so I have to take, now again, if you have your calculator out, just lay it there. We don't need it yet. So we're going to have the ln of 6,000 divided by 5,500. Notice it's as a whole, okay, because this guy right here was being divided before we took the ln. So we have to be very careful. All right, equal sign, ln, all this junk. So 1 plus 0.048 divided by 12 to the 12t. Now, the whole idea behind us taking the ln is so that we can take this exponent and we can bring it out front, right? Because that's what the rules of the logs allow. So without having to rewrite all this, because I'm running out of space, I'm just going to go ahead and do that. I'm just going to say, okay, here's 12t, and he's no longer there. Everyone agree with me? Now, over here, there is no exponent, so I'm not bringing anything down. So the left-hand side doesn't change. Now, this is a big problem, okay? Meaning there's a lot of information, but we have to just keep our heads on straight and say, okay, well, I see T. It is right here. And I say to myself, what is happening to T?
It's being multiplied.
By what?
12.
12. And also
your ln 1
all of
plus.
that. So what is the opposite of multiplying by 12 times the ln of blah, blah, blah?
Divide.
Yeah. And what I do to one side, I absolutely must
do to the other.
And so here's what I'm going to do. I'm going to say divide by the number 12. T has to stay here. And then the ln of all of this stuff. I don't care what it looks like. All I care is that I'm doing it to both sides. So 12 ln 1 plus 0.048 divided by 12. Now again, this is big and bad. I don't really care. And so what's going to happen is this 12 and this 12 gone. The ln of all of this stuff and the ln of all of this stuff gone. And so, hey, guess what? I solved for T. And so is my exact answer, because you're going to have both, my exact answer will be T equals the ln of 6,000 divided by 5,500. Notice that, again, it's just one ln all over 12 ln of 1 plus 0.048 divided by 12. That's my exact total answer. Now, those of you who want to try without me, if you type this in, you should get 1.82. So give it a go. If you're following along, type in exactly what I say. Okay, here's what you're going to type in. Hold on, let me make some space. Okay, this is what you're going to type in. Let me do it in green so it pops. I've lost my place. Okay, you're going to hit the LN button. Parenthesis pops up. You're going to type 6,000, division sign, 5,500, close division sign, hit enter. Okay, do that first. So I'm going to do it too. Make sure we're keeping everything going here. 6,000 divided by 5,500, close, enter. If you do that, that gives you like 0.087. Okay, but again, don't round it or anything. I'm just making sure that you're getting this. Okay, the next thing that you're going to hit is the division sign. Okay, then you're going to hit a parenthesis. And then you're going to type in this bottom. So 12, ln, a parenthesis already populates. You hit 1 plus 0.048 divided by 12, 2 parentheses, and then hit enter. And when you do that, you should get 1.82. So take a sec. Let's all make sure that we're typing this in. Let's see what we get. Okay, that's what I got. So you take a second and let's make sure that's what you get too, please. And I've been trying to tell you guys how important our calculators are. Okay, we use them. Oh, Lakin got it. Okay, good. We use them for everything pretty much in this whole section.
Yeah, one little button difference, it really makes a difference.
Yes. So in addition to just giving you the support assignment, as soon as we get done here, since I changed my mind a little late and I didn't have time, I'm going to go where the support assignment is found, and I am going to type in the answers to all of them. There's 11 questions. Okay, that's not outrageous. I'm going to type in the answers to all of them so that you know what you're working toward. Okay, because I hate sometimes giving you a problem and being like, good luck. I'm going to be outside kayaking. Good luck. Okay, I want you to have something so that you can work toward it, okay? And so that way, someone said one calculator mistype in your SOL pretty much. I want to make sure that doesn't happen to you, okay? So on this particular problem, only 2-3-ish people maybe have told me they've gotten it. Yes, no, maybe? What?
I got it.
I
Okay, so then let's go back, okay? Let's go back to this little weird saying, okay, on the front of the page when I said if you need to find the time, divide, ln, divide. That's what this means, okay? Our question said, hey, how much time is it going to take? Well, we set it up. We divided first, and then we did the ln, and then we divided again. And so technically, we only did 3 steps, even though it looks like more than that because these are big. That's the problem. That's it. What do you think?
Wasn't bad.
It's
You
not
have to follow
bad.
through with your steps and make sure you don't put the wrong buttons in your calculator.
Exactly. See how scared you guys were? Remember, like 4 days ago when everyone was like, ah, okay, it's not that bad. All right, I have one more problem that I want to do with you, and then I'll let you see what you think, and we'll either be done or we'll do some more. Okay, whatever you want. All right, so here we go. I've lost track of what this is, so it's just going to be the last one unless we need to do otherwise.
I
So
think
here we are.
it's 7.
It doesn't matter. I don't know. Okay, so here's what was going to happen. We are going to be given this formula. A of t equals a sub 0 of e to the negative point. And now this is, be careful because earlier I miscounted and my whole problem was wrong. There are 3 zeros, and then it's 1, 2, 1, t. And we are going to be talking about decay again. But again, we're going to be solving for t. So it's a lot of what we just did. Okay. And again, we are going to divide, ln, divide. The reason that I want to do this problem is because you're going to see this. And even though it's not a compound interest problem, it's still applicable to real life, and you still have to be able to do it. So here's what we're given. And a couple of days ago, we talked about something that was called carbon 14, and I said we don't really care about the chemistry part of it. We just need to know how to do the math. I'm still on that kick. Okay, so part A wants us to find the half-life of carbon 14. Well, not half, oh my gosh. The half-life of carbon 14. Okay, half-life. And so we already know from the other day, okay, I'm just going to write it down. it told us in our notes a couple of days ago that the half-life was actually 5,728 years. Well, let's prove that to ourselves. Okay, let's actually calculate it. So here we go. When we started out the other day, we said that the half-life was how long it took for half of your initial substance to decay. So if we started out with A sub 0, because that was our initial, how much is left after the half-life has expired? Well, exactly half of it. Okay, so starting out the other day, we literally said that 1/2 of my A sub 0 is equal to my actual function. Okay, so let's not overthink this stuff, all right? It's very straightforward. There's a lot of repetition. So we're going to start out by saying, hey, guess what? Half of my initial substance is going to be left from what I started with. Does that make sense? Do you agree to that?
Mm-hmm.
Okay. And so now my formula, bam, just like that, it's set up. And so according to my rules over here, I have to divide, ln divide. Well, okay. And so again, I'm trying to solve for t. Well, t's up here in the exponent form, or in the exponent location. And so step number 1 is I need to divide by something. Well, on the last page, or on the previous problem, we had a number right here, and we divided. In this case, I don't have a number, but I have a value, a sub 0. And so let me divide both sides by a sub 0. Well, as it just so happens, there's an a sub 0 on both sides. And so what's going to happen is they're going to totally and completely divide away, totally gone. And so what that leaves me with is 1/2 equals e to the negative 0.000121, t. Okay, this problem looks a little bit better because it's nowhere near as big. Okay, and so since the t value, though, is still up in the exponent area, what am I going to have to do? So I divided, check. What am I going to have to do next in order for me to bring that down?
Take the ln.
Okay, and so I'll take the ln of both sides. So I have the ln of 1/2 equals the ln of e to the negative 0.000121 t. Okay, good. Now, the whole purpose of me, so I did the ln, check. The whole purpose of me doing the ln is so that I can bring all of this out front like a normal number. So let's do that. So we're going to have the ln of 1/2 equals negative 0.000121 t, and that's a normal number, so to speak. Now, quick question. The other day we talked about what happens when we take the ln of e. Isn't that just equal to the number 1?
Yeah.
Yeah. And so what's going to happen is we get to go boop. We don't even need that 1 there. And on this side, there's nothing else going on right here. It's just as a normal number, negative 0.000121 t. And then I say, okay, well, here's t, and t is a normal number now. And in this instance, t is being multiplied by negative 0.00121. And what is the opposite of multiplying by negative 0.00121?
Divide.
Okay. And what I do to one side,
You have to do to the other.
okay, it's over here, la, 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 la. And so what's going to happen is my exact answer is t equals the ln of 1/2 divided by negative 0.000121. This is my exact answer. And once you get that thing typed into the calculator the right way, you're actually going to get a nice, neat, even number, which we already knew we should get because that was given to us in the notes a few days ago. But as far as the answer goes, this is it. So take a sec, however you type it in on your calculator, can you get 5728? If you do, just sit there for a sec. Chill out. If not, then we got to talk about it, okay? Anybody getting it?
Yep.
Okay. One person got it. Two persons got it. All right. Okay. Okay. Several more people are getting it. Okay, good. Okay, so now that part A is done. We found the half-life. No problem. Now, what's going to happen is the other day when we talked about decay, once we knew the half-life, we started with a sample and we said, okay, well, how long, how much will be left after 10 years pass or 15 years or whatever. Well, now for part B, so let me get a fresh page here. Part B wants to know if you start with 1.5 grams, whoa, fix that. 1.5 grams of carbon-14. old, hold on one second. I read the problem wrong, so hold on one second. Let's get rid of the word start, okay? I don't know what I was thinking. Let's say we need to find the age of something that has 1.5 grams of carbon-15 in it, okay? So something has died, and it now has 1.5 grams of carbon-14 in it. We need to figure out how old it's been. Based on the fact, given that a living organism has 2.3 grams. Okay, so we have this organism of some sort. If it were alive, living, it would have 2.3 grams in it. It's dead, okay? And it has 1.5 grams in it. I need to know, how old is it? How long has that thing been dead? Okay, really, that's what I need to know. So how old is it? Question mark. And we're going to use the same formula, A of t equals A sub 0 of e to the negative 0.00012 Okay, well, the thing that we need to do first is read through our problem. And I kind of butchered it. I apologize. It'll be much nicer written on the support worksheet. It's too much writing. We need to list everything that we know. And then we need to, since we're solving for t, we need to divide, ln divide. And we just did that. And so here we go. Let's keep going. A living creature has 2.3 grams. So that's going to be my A sub 0. That's how much you start with, right? When you're alive. Well, my A of t, which is how much I will have in the future, in this case is 1.5. I started with 2.3. I don't know why I put a 5 right there. I died. And now I have 1.5. And the only other variable in this entire problem is t. And t is what I don't know. And so my formula is going to be set up like this. I'm going to have 1.5 equals 2.3 e to the negative 0.000121t, like that. And so the difference in this problem and the one that we just did is these two guys right here are no longer the same. So they're not just going to go away like they did in the last problem. But we still have to divide, ln divide. So let me pause for 1 second. What are your thoughts on the setup of the problem? Any issues with the way this looks so far? Okay. So step 1 is to divide. Well, I need to divide by the 2.3. And again, notice I'm not even mentioning calculator. So we divided. So the 2.3 is gone. The next thing I need to do is take the ln of both sides. So I will have the ln of 1.5 over 2.3 equals the ln of e to the negative 0.000121t. Now, again, the whole point or the whole reason of me taking the ln is so that this guy can come out front as a whole number. I also know that me taking the ln of e is just 1. So I get to just go boop and scratch that guy out. And so I'm going to do two things at once here. I'm going to bring that variable out front like a normal number, and I'm going to get rid of the ln of e because why the heck not, right? Why not save myself some space and some work? And so by doing that, I will have the ln of 1.5 over 2.3 equals negative 0.000121t. And again, what's happening to t?
Multiply,
And so I need to,
divide.
okay. And so I do that, negative 0.000121. And then of course these guys gone. And so my exact answer, all this junk, my exact answer will be that big old nasty thing. Okay, and then we'll type it into our calculator and we'll see what we get. So the exact is t equals the ln of 1.5 over 2.3 all divided by negative 0.000121. That's the exact answer. Okay, so let me pause for a second. What are your thoughts? Any major issues with getting that far? Because it's a repetition. We divided, we took the ln, we divided again. And so go ahead. No? Okay. For those of you who are just kind of maybe working a little bit ahead of me, which is totally fine, here's the answer. Okay, if you're waiting for me to tell you how to type it into your calculator, here's how you're going to do it. You're going to do ln button, parenthesis pops up, 1.5, division sign, 2.3, close, enter. Okay, you get whatever. I don't care what it is. It'll be some, some value. And then, okay, great. Lakin got it. Good. And then once you hit enter, then you will hit the division button and you will hit negative sign. Make sure you don't hit the subtraction sign. Make sure you hit the negative sign. So this is NEG for negative. And then 0.000121, and then you're going to hit enter again. And that's what should give you this whole number. Actually, to be honest with you, I can't remember if it was a whole number or if I rounded. Is it a whole number? Or did you round?
You round because
Okay.
it's 3532.5.
Yep. We round. Okay, and so ta-da! Done. So as far as this section goes, I'm done. As far as notes go, I should say. And so it's up to you guys to decide. Do you got to give me probably 5 or 10 minutes to go through to the support assignment and put the answers in, type them in rather, so you can see what they should be. But do you guys want to do any more problems? I have some other examples. Or do you feel like, I just need a little practice, don't need more problems? Okay. Okay, good. So since there is no Hawks, again, it's still available to you. I'm going to go in and make it so where it doesn't count. I'm going to leave it up there in case anybody wants to go in and practice. I'm not going to totally hide it from you, but I'm not going to make it count towards your grade. So having said that, then what that means is, hold on, let me get my, okay, Sebastian, if you do, they're going to look similar to this, sort of, in the fact that you would use the ln to get rid of it. So I honestly don't remember. I didn't give you any, to my knowledge, but I can't remember. I don't think so. So let me get rid of my, maybe, how do I do this? I always struggle. Stop share, get my camera up so you guys can see me. Okay, so the support assignment's out there. I'm going to upload the answers in a few minutes. I'm going to type them in, so it takes me a second. The work that you do, okay, I have mine done. Okay, the work that you do has to match the work that's actually right. Otherwise, I'm going to say, look, okay, I'm not saying you cheated, but somehow you magically got the right answer and your work is all wrong. Okay, so please make sure that's not the case. Can anybody think of anything they need to ask me or tell me? Okay. All right, well then that's it. When you come in tomorrow at 2, there's no more new stuff, so we're totally done with new stuff. We are just going to, what I think probably, the Unit 5 test will be available to you Wednesday night, Thursday morning at midnight at 12:01, and it will be due Friday night, 11:59 p.m. So you have almost 48, or no, you have the 2 full days, all of Thursday and all of Friday. So yeah, almost 48 full hours. Okay, so when you come in tomorrow, we're just going to do more problems like this. I'll let you ask your questions, but there are no new stuff. Are we going to Zoom Wednesday or Thursday? I plan on Zooming you tomorrow at 2, which is Tuesday, Wednesday at 2, and then I do not plan on Zooming you Thursday simply because you're taking the test at that time. But if you as an individual need to Zoom me on Thursday, you can. I just need to know. Some of you I've been a little out of touch lately. I did have some internet issues, but then I also went on a big hike yesterday. So I've also been trying to make the most of my time and not just be cooped up in my house. So if I don't get back to you, I'm not ignoring you. I'm either napping, cooking, cleaning, or I'm outside, okay, with the dog. So that's it. You need to Zoom me, let me know, we'll make a plan. Anything else? Lucky? Yeah, I know. I am lucky. I'm very, very fortunate to be able to go outside. All right, guys. If you're good, I'm good. If you need to stay and ask me questions or tell me things, fine. I sent back to you your support assignments for 7-1, 7-2, 7-3, and 7-4. I put little notes. I put the key. It's up to you to kind of say, hey, I'm doing well, or hey, I'm not doing well. And if you're not doing well, you got to talk to me, okay? I'm done if you're done. Have a good day. It's very nice out. Go spend some time outside. Message me later, okay? All right, I'm going to sign off unless you need me. Okay, bye, guys.